Alright, let's go through the question 2, the part 2. Okay, the curve has a parametric equation to be x equal to something, then y is equal to cosine inverse 2 theta, where theta is more equal to negative half, more, less or equal to 0. The very first part, we are asked to find the dy dx. So this one, I will say quite simple. So first we use the dx d theta, then we use the dy d theta. Right? So the dy d theta, this one, when you do the differentiation of cosine inverse, you use the MF27. Then after that, right, you can use the dy dx, because dy dx we just know is equal to dy d theta divided by dx d theta. So you do the manipulation. Yeah, hopefully you are able to get dy dx, right, to be 1 over 2 theta. So that is 1 over 2 theta for the very first part. Okay, the second part, we are asked to do this. So we are given Q is a point moving on C, right, such that the dy dt is given to be 0.25. So this dy dt. Okay, then they ask us to find the value of theta, right, such that the rate of change of m is about 1 unit per second. Wow, this one looks like a rate of change question, but not a fully a rate of change question. So first we start off with m equal to 1 over 2 theta. Of course, it's equal to half theta to power negative 1. So with this, right, I simply just do the implicit differentiation. dm dt is equal to half, and then powering down, then power minus 1. So it's minus 2. But don't forget to put a d theta dt. So this will result in a form of minus half. Then the theta square, maybe I just put here, theta square, then d theta dt. Okay, then with this, we go back to, because they actually give us one more information, is that we go back to dy dt. So dy dt, they actually tell us is 0.25, meaning it's 1 quarter. So of course, by the first thing that comes to mind is the dy dt is equal to dy dx multiplied by dx dt. But apparently you can see that we do not have this. This one is in terms of theta, and I do not have theta, so I cannot find dy dx as well. So maybe we do a bit of changing. So means, for example, this one can't do it already, right? So we just use dy dt. Because since they give us dy dt, right, we must definitely use dy dt is equivalent to dy d theta, or dy d theta multiplied by d theta dt. So you can see that the d theta and d theta is gone. So left hand side is dy dt, the right hand side is also dy dt. Okay, then by one look we know that, okay, dy dt is 1 quarter, 0.25. So shall we maybe make d theta dt, right, to be in terms of dm dt, because dm dt they actually tell us is 1. So this is 1. Okay, so meaning that maybe I can maybe right here. So this one, dm dt is equal to minus 1 over 2 theta square d theta dt. So this whole thing right here is 1. So just do the simplification. So this will give you minus 2 theta square. So it's minus 2 theta square is equivalent to d theta dt. Okay, then you can just do the replacement. So this one just sub inside. So this will become 1 quarter equal to dy d theta, right, multiplied by negative 2 theta square. So I simply just move this thing to the left hand side. When I move, must be divide. So the whole thing, right, will be equivalent to minus 1 over 8 theta square is equivalent to dy d theta. Okay, so I stop here first. So dy d theta equal to negative 1 over 8 theta square. So by one look you thought, oh, might be a differential equation, but actually it's not. So I need to go back to the very first part. The very first part, we actually got something, right? We got this dy d theta. So this dy d theta, hopefully I differentiate correctly, is negative 2 over root 1 minus 4 theta square. I just need to sub them together. So meaning, so okay, from the first part, right, from first part, my dy d theta is equal to minus 2 over root, okay, minus 2 over root 1 minus 4 theta square. Let's double check first. Yes, correct. Okay, then I equate them together, then can solve already. So means that minus 2 over root 1 minus 4 theta square, right, is equal to negative 1 over 8 theta square. And then just do a bit of cross multiply, right? So this will give you 16 theta square is equal to square root of 1 minus 4 theta square. And then I need to square both sides because I want to get rid of square root. Right? So I square both sides, right? So 16 square, let me do the first one. 16 square is 256 theta to the power of 4. Then the right hand side will be just 1 minus 4 theta square. Then everything move to the left hand side. 256 theta 4 plus 4 theta square minus 1 is equivalent to 0. Okay, then for this, right, it's time for GC. From GC, right, so this one you just use the poly app. So poly app, then after that just sub in every respective coefficient. So the theta to the power of 4 is 256, no theta 3, then after that theta square is 4, no theta, so the constant is minus 1. So I solve it. So you will get 4. 2 will be complex, another 2 will be real. So from GC, I get the real one. Theta is equal to 0.235 or negative 0.235. So of course, we must accept only one value because they say the value, right? Yeah, so they say the value of theta. Then we look at the range, the domain. So theta is more equal to negative half, less or equal to 0. So definitely I must reject the positive number here. So this one is rejected. So means that theta, right, is equivalent to negative 0.235, which is consistent because they say theta, right, lesser or equal to 0, more or equal to minus 0.5. So you can see that actually this one is inside the domain. So that is how we actually solve this question.